A particle of mass m moving in the x direction with speed 2v is hit by another particle of mass 2m moving in the y direction with speed v. If the collision is perfectly inelastic, the percentage loss in the energy during the collision is close to which of the following options? When we say that the collision is perfectly inelastic, we mean that both the masses stick together and move as a combined mass after the collision. We can still apply conservation of momentum and get particle of mass m moving with velocity 2v in the x direction plus particle of mass 2m moving with speed v in the y direction, and this would be equal to 3m into the velocity of the combined mass. Since m can cancel out throughout the equation, we have 2v into I cap plus j cap is equal to 3 times the combined velocity, or the combined velocity is equal to 2 by 3v into I cap plus j cap. Now we need to find out the percentage loss in the kinetic energy. So what is the kinetic energy before the collision? Let's call it capital K1. This is equal to 1 by 2 into a particle of mass m moving with velocity 2v whole square. And the second particle has a mass of 2m and is moving with a velocity v. Square it. So we have 1 by 2 mv squared into 4 plus 2, or this is equal to 3 mv squared. What is the kinetic energy after the collision? Let's call it K2 is equal to 1 by 2 into 3m, and what is the velocity, or rather the square of the velocity after the collision? So that would be 2 by 3v whole squared plus 2 by 3v whole squared again. Since they have 2 by 3v is the velocity in the x direction and the y direction. So this simplifies to 1 by 2 mv squared into 3 times 4 by 9 into 2. So this is equal to 4 by 3 mv squared. So how much of the kinetic energy has been lost? So percentage change in kinetic energy would be K1 minus K2 minus, or rather divided by K1, and that is equal to 3 minus 4 by 3 divided by 3. So that is 9 minus 4 divided by 9, or 5 by 9. And 5 by 9 is close to 55.55%. Therefore option A is the closest to the answer.